Okay, this is the third and final example he gave in the lecture, and I reckon this one's going to be on the exam because there's a question like it in the worksheet. Alright, so he's drawn it for you, but we could have figured this out ourselves. So he's told us that z equals x squared plus y squared, and just seeing this we know immediately that that is a cone, and we have z equals x squared plus y squared, which we know is a sphere. But the trick is we need to know where the origin of this sphere is. Is the origin at the center? No, because this isn't a constant, it is a variable. So therefore we need to complete the square in order to find where the origin of this circle, of this sphere is. So do you remember how to complete the square? Y squared plus z squared minus z equals 0. So we've just taken the z to the other side. The next thing you want to do is you want to half the value in front of the z, then square it. So in front of the z is 1. What's the half of 1? It is a half, that's right. So you're going to plus a half, then square it. And what you do to one side, you have to do the other side. Square it. Then you can rewrite it again. Now, this can be rewritten as z minus a half squared. And then this becomes 1 on 4. So this really is what we want, because this tells us where it's located. So this tells us that it's shifted 1 up in the z direction. As you can see here, the origin is at half. And now you might say, well, what good does that tell us? Well, the reason why this is so important is because we measure rho from the origin. So the distance from there to there is different from the distance from here to here. When it's centered at the origin, rho, the radius is the same. But now that we're not at the radius, it's all different because it's centered at 1. So how do we solve for rho now? Well, what we do is we take this equation and we go, alright, what does z equal? Well, z equals rho cos of theta. And what does x squared plus y squared plus z squared equal? Equals rho squared. So we could rewrite this as cos theta equals rho, just by dividing each side by rho. And therefore, this tells us that rho exists between 0 and cos of theta. So then we also have to figure out what theta equals. Theta is always an easy one. We're going right around, so it's 2 pi. And we have to figure out what phi equals to. And phi is just from here to there. So it is pi on 4. Now that we have those 3 values, we can solve our equation. So we're going to get, what are we going to get? 2 pi 0, pi on 4, 0. Cos theta 0, and then p squared sine rho squared sine theta d rho d theta d phi d theta. My goodness. Alright, now what do? We now integrate with respect to, well, first thing, there's no theta in here, so let's just take 2 pi out. we integrate with respect to rho, so we're going to get P3 on 3 cos of theta phi. And we've still got our sine over here, d. This should probably be over here, but screw it. Next, what do we do? Let's change color. So 2 pi cos phi no, this should stay there. Don't forget this, pi on 4, 0, sine of theta d phi, sine phi. Now what do you do? Well, now you have 2 phi's that you have to integrate. So let u equal cos phi, then you can go du d phi equals sine of phi negative sine of phi. Yes, negative. Then you can go, well, d phi equals du negative sine of phi. Therefore, you go 2 pi on 4, 0 u cubed on, actually, let's take this 3 to the front. That's nicer. Sine phi. We can change d phi into this. Du negative sine of theta. And then we can go, hey look, sine cancels. We also have to remember you got this negative here, so take negative to the front. So now we have to integrate that, which is easy as pie. Negative 2 pi on 3 u to the 4 on 4 pi on 4 and 0. This therefore will be negative 2 pi on 3. U was cos minus negative 2 pi on 3 minus 1 on 4. If I was in an exam, I would leave it there. And he kept solving it, but to be honest, I don't know how he did it. But that is the answer.